Let's take a look at how to fill in the data table for our molecular shape lab. So if we want to do one, say like pH 3, the place to start is by drawing your Lewis dot diagram. So if we want to draw a Lewis diagram for pH 3, we really need to know how many valence electrons it has. So if we go look for phosphorus on the periodic table, we see it's in column 15, it's going to have 5. Hydrogen is in column 1, so it's going to have 1 for each, but notice that we have 3 hydrogens, so we need to add 3. That gives us a total of 8. That's how many need to be in my picture when I'm done. We know that the one that's different than the others, or the one that makes the most bonds, goes in the middle. If you're not sure about which one makes the most bonds, you can draw a Lewis dot diagram for each atom and see. We said hydrogen had 1 valence electron, so it looks like that. Phosphorus has 5. We put 1 on each side, 1, 2, 3, 4, and then we go around again until we get the number we need. So there's the 5. It has 3 lone dots, therefore it can make 3 bonds. Phosphorus will be in the middle. So you can just kind of duplicate this here, only instead make a line for each attachment that's going to have. We know there's going to be 3 H's, so we'll put 1 H in each spot. And there's your Lewis diagram. Notice that each H has 2 electrons. Remember, a line counts as 2. And then if we count around the phosphorus, it has 2, 4, 6, 7, 8. The other way you could think about that is to put the one that's different in the middle, attach the outside things by a single bond, and then compare the number of electrons in your picture to the number that we came up with over here. Here's 2, 4, 6. I have 2 left, and all of the extras go on the middle atom as pairs. So either way you do it, you get the same picture. So I can copy that Lewis dot diagram, making sure to write the unbonded electron pairs up here. So if you don't, it doesn't follow the octet rule, plus it will give you the wrong count when you go to fill out this part of the data table. The first empty box here is for the number of atoms attached to the middle atom. So attached to the P, I have 1, 2, 3 atoms. The second box is the number of unbonded electron pairs, bonds that are dots that aren't involved in bonding, so lone dots on the middle atom. As a pair, I have 1 pair of dots. It's 2 dots, but it's 1 pair, so my numbers are 3, 1. From the Quizlet that you're supposed to be practicing, you know that a 3, 1 is a trigonal pyramid. Now, to do the bond polarity, it's super easy. You're just looking to see if anywhere in the whole molecule you see 2 different atoms stuck together. If you do, then that bond is at least partially polar. So look, there is a polar bond because I have 2 different atoms stuck together. So bond polarity, I'm going to say polar. For the molecule polarity, sometimes the shape of the molecule cancels out the polarity of the bond. But if you ever see dots on the middle atom, or if you see outside atoms that are not all identical, that's going to make it polar. So here I have dots on the middle atom. That makes the molecule polar. So you really need to start with your Lewis diagram. Don't forget the unbonded electron pairs. Make sure your middle atom follows the octet rule. That will help you come up with the numbers, and then you can use the numbers to figure out the shape. Polarity of the bond, different atoms makes it polar, and then polarity of the molecule. If it's symmetrical, you would say nonpolar, but if the outside atoms are different, or if there's dots on the middle atom, then you're going to make it polar.